All right, IBAISL2. We're going to talk about 6.2 today, which is the line of best fit. I already kind of showed you guys how to find the line of best fit using lin reg on your calculator, but we'll come back to that. So first example, I believe I've shown you this data before. We got some math tests up top and some bio tests on the bottom. So each of these represents a student. Like this would be one student. They got a 20 on their math test and a 24 on their bio test. First thing we're going to do is find the means of the math and the bio. The mean just means the average. So you add them all together, divide by how many there are. If you do that with the math tests, which are labeled X, then X bar is equal to 32.75. If you do that for the bio tests, the Y bar is 25.25. Now, we're going to take that data and draw a scatter plot. So remember that's putting the X's as L1s, the Y's as L2s, and then turning your stat plots on and using zoom stat on your graphing calculator. If you do that, you should get something like this here. So we're going to talk about a line of best fit by the Buyeye method, which is the worst way to find a line of best fit. We're going to use this mean point of 32.75 and 25.25. So if I do a little zoomer here, 20 X of 32.75 and a Y of 25.25. So it's like somewhere around here. The Buyeye method is like try to draw a line that goes through this mean point and separates the data, so about half of the data is on top and a half is below. So let's see if I can do one by eye. Like, nope, that's not a thing. How about this? Yeah, so like a little bit, something like that. Do you see that I tried to get 1, 2, 3 above and maybe tried for 3 below, but it's something like that. It's not perfect. It's the Buyeye method. So you just kind of try to get about half above and a half below, and it goes through the mean point. Okay. So that's really it for the Buyeye method. It's not that great. There's another method called the least squares regression line. And this is going to be actually finding the y equals mx plus b of the line of best fit. It has to do with residuals. Like, I don't know how much I want to go into the math behind it, but like if we go back to this drawing right here, like this distance from the dot back to the line, or this distance here, or this distance, is called a residual. And this least squares method tries to minimize residuals. So this is like a y equals mx plus b equation, but there's so many weird parts to it. This whole top right here is this whole equation. Sigma xy minus sigma x sigma y divided by n. Those sigmas are just adding machines. They mean add up all the things of that kind. So let's make a note that the sigma is an adding machine. Switch highlighter. This here in the bottom, sx squared, is this whole equation here. So it's like this goes into the denominator there, and this whole thing goes into the top here. Yep. So I'm going to walk you through how to do one of these by hand. So we're going to use these data points, 1, 2, 3, 4, 5, 3, and we're going to find a least squares regression line by hand. The first thing you're going to want to do is extend this table because there's 3 more columns that we need. The columns are x, y, x is already there, y is already there, and we're going to do sigma x squared. Make sure I wrote something down right. Yeah. So here we have another square. So those are the things that are going to go into these columns here, the sigmas. So we have to do an xy column and an x squared column. And down here below, we're going to do totals. So sigma x literally means adding up all the x's. So sigma x is 1 plus 3 plus 5. So that's 9. Sigma y is going to be these three numbers added together. So sigma y is going to be 7, 9 as well. Do we need means? Okay. Then xy means multiplying x and y together. So we're going to multiply 1 times 2 to get 2, 3 times 4 to get 12, 5 times 3 to get 15. And then the x squared column literally means taking all of the x column and just squaring it. So this becomes 1, 9, 25. Oh, I forgot to do my sigmas down at the bottom. Sigma xy is equal to this whole column added together, so that's 29. And then sigma x squared is this whole column. So 35. Now I've got all the ingredients I need to cook up this equation. So the first thing we're going to do is sxy. Now in this equation up here, sxy is sigma xy, which I already know from it's right here, 29. So sigma xy is 29. And then sigma x and sigma y are both 9. So this will be 9 times 9 all over n. Now n is how many data points I have, and that is 3. There are 3 data points. So if you simplify that, let's see, that's 81, 29 minus 81 thirds. Or no, 9 times, are they messing up? I think the book might be wrong. Oh no, we're good. Yeah, so this is 2. Now that's just sxy. That's just part of the master equation. So the master equation is this right here. So we just found that top piece. Now we need to find sx squared, which is this equation here. So sigma x squared minus sigma x squared, or sigma x quantity squared. So sigma x squared is 35. And then we're going to take away 9 squared over 3. The 9 is this part, sigma x, and the n is 3. When we simplify all of that, we get 8. Now we're so close to the final equation, but notice in the final equation that we need y bar and x bar. So we're going to list those out as well. X bar, you would just take the average of the x's, add them all together and divide by 3. Well, adding them all together was 9 and then divide by 3, so x bar is 3. Y bar is adding these all together, which was 9, and dividing by 3, so they just happen to be the same number in this case. That doesn't always work out like that. Okay, you guys, we've got the big 4 ingredients to be able to do the master equation. So here, I'll write the master equation one more time. Y minus y bar equals sxy over sx squared times x minus x bar. So this s sub xy is 2. The denominator is 8. X bar is 3, and y bar is 3. So we get y minus 3 equals 2 over 8 times x minus 3. Now we just need to simplify that. So let's see, 2/8 is a quarter. We'll do y, I'll leave this side alone, and then we'll distribute the quarters. So we get quarter x minus 3 quarters. Then we'll do y is equal to, we'll kick that -3 over to the other side. Then we need a common denominator between these two. So y equals 1/4 x minus 3/4 plus 12/4. So that's going to be 9/4. This is the line of best fit using the least squares regression model. Remember that minimizes the residuals. It helps you cut through the data as best you can. The last method is going to be using linreg on your calculator. So we're going to take this table of data, which I believe is like at a bus station. The temperature each day is X, and then the amount of water sold is Y. And these are different days across the top. So you're going to punch this into your L1 and this into your L2. Draw a scatter plot, and it looks something like, I'm not going to make this exact, but it's like, something like that. So my first thought is that it has kind of an uphill correlation, but it doesn't seem super strong. It's like maybe moderate. Not sure. I'd definitely look at that Pearson's value. Now, you guys, this part, find the regression line equation. Like I said, you're going to punch all of the x's into L1, or the temperatures, and all of your water sold in L2. You do that with the stat edit button, and then make sure your L1 and L2 are good to go. Then you hit stat calc. Number 4 is linreg ax plus b. You're going to pull your x list from L1 and your y list from L2. Leave your frequency list blank, and then hit calculate. So my calculator tells me that the line of best fit is 8.05x minus 24.75. This is the same thing you would have gotten doing the least squares regression, but you wouldn't want to do a least squares regression with a table like this because there's so much computation. I mean, you could do it. It would just take like 15 minutes. Who's got that kind of time? Part C, use your equation to predict how many water bottles for 19.5 degrees Celsius. Well, remember that temperature was our X and water bottles are the Y. So if they're giving us a temperature, I got to plug that in for the X. So this is Y equals 8.05 times 19.5 degrees Celsius minus 24.75. So if I plug that in, crunch, 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 it's going to be 132.2. Yeah, that's it. 132 water bottles when it's 19.5 degrees Celsius outside. Okay, you guys, good luck with your homework.